Assalamu alaikum warahmatullahi wabarakatuh. Alhamdulillah, we have actually finished chapter 1 of the book, which is on the first creation, which is the metaphysical creation of Allah subhanahu wa ta'ala, not this physical universe. So now we're moving on to this physical universe. And the second chapter, we're going to talk about the Big Bang, right? Now this is going to be a little bit interesting, but at the same time, we're going to talk a little bit more on the scientific aspect of the Big Bang, and I'm going to, I mean, go a little bit deeper on this scientific aspect of it. So I'm going to talk about atoms and subatomic particles and some of the subatomic physical or physics theory, right? Because we need to have some a little bit of understanding of what those things, the world of subatomic particles, before we can actually appreciate the Big Bang. And also from there, we move on to what Allah subhanahu wa ta'ala says about the creation of this universe. Okay, so we have covered all these things, the first creations, the Nurun Nabi and creation motif and physical, metaphysical time scale. And we move on to chapter 2 on the Big Bang. Now, in that book, I actually have this quote from Albert Einstein, which I think is very interesting. Albert Einstein, you know, is the founder and the, what do you call it, the one who proposed that theory on relativity, and he is also, as you know, given the credit to come up with that the most what do you call it, the most famous equation, which is E is equals to mc squared. E is equals to mc squared is the root, or is the main thing of atomic bomb or nuclear explosion or thermonuclear explosion. Everything comes back to that real equation. The equation is E equals to mc squared. So he was credited as the one who actually came out with that equation. So he said, right, according to his understanding of this universe during that time, he said the most incomprehensible thing about the universe is that it is comprehensible. See, the most incomprehensible thing, right, something that we cannot even imagine or fathom, that this universe with all its complexities is actually simple. Under the underlying principles are actually simple, and we can actually understand it. We can build equations from it, and after that we can actually go back in time and see how the universe started, right? And the, what do you call it, the laws of this universe. So that is according to Einstein. But unfortunately, in certain aspect, Einstein was wrong, because he said this before the full, what do you call it, discovery and acceptance of quantum mechanics. There's another branch of physics, the modern physics. Now, quantum mechanics is incomprehensible, right, for our mind, because it actually entails that a particle can be a particle and can be a wave, have a wave-like properties at the same time. It depends on the observer. So if you observe it, then it will collapse into either a particle or a wave function. So that is basically incomprehensible to most people. So even Albert Einstein cannot accept, he could not accept that quantum mechanics, and he tried in vain for the rest of his life, and he was already in his 40s and 50s, to try to disprove that quantum mechanics, but he couldn't disprove it. And right now, quantum mechanics is something that is taken as a fact. It is the cornerstone of our technology. And if you look at our satellites, our GPS system, even the computers, even the technology that we're using right now, Zoom and the computers, all these are based on quantum mechanics. So we can see actually the most or you can twist it the way, the most comprehensible thing about the universe, it is that it is incomprehensible. So it's the other way around right now. So during Albert Einstein time is the most incomprehensible thing about the universe is that you can understand it. But right now is that the most comprehensible thing, the one that you can understand about universe is that it cannot be understood. This is universe. Now, this chapter 2, right, I started with the discussion of the theory of the Big Bang itself. And the Big Bang, the theory of Big Bang actually can be broken into two parts, right? The first part is the agreed model, which almost majority of astrophysicists, scientists, right, mathematicians, they agreed on this model. Now, the second part is the speculated part in which there are a lot of disagreements among physicists and astrophysicists and mathematicians, because the speculated part is something that make use of arcane mathematical equations, long mathematical equations. So it's not based on observation. It is not based on physical evidence. It is more based on the intuition of the scientists involved, right? And how that scientist came up with, how should I say it, mathematical equations that he can tweak it here and there and support his proposal or his hypothesis. It's not even a theory sometimes, right? It's just hypothesis. So that is a speculated part. So like all other branches of knowledge, right, there are always the agreed part and the things that are on the horizons, the fringes, which still being discovered and still being discussed by scientists or by the, what do you call it, the proponents of that field of knowledge. All right. And in our deen is also like that. There are things that we all agreed upon, right? Those are the Arkanul Deen, Arkanul Islam, all those things we agreed upon. But there are also the things that we speculate upon, right? The scholars speculate upon. Those are the fringes of our deen, right? Whether it's right or wrong, and then that's why we have all those ijtihad and fatwa and so forth. Those are the speculated part. So this is what human knowledge is all about, right? We always have the core knowledge that we all agree upon, and there are always the secondary, the fringes knowledge that people are still arguing upon before before they agree, and then they incorporate it inside the core part of that field of knowledge. So two parts, the agreed part and the speculated part. Right now, the agreed part is called the standard model, right? The standard model of how this universe came about. Now, the Big Bang actually talks about the objective of the Big Bang theory is to discover how this universe became populated with stars and galaxies. And that's actually age-old question, right? The philosophers in the past, they try to understand why actually there are stars in this universe. When you look up there, they see stars. And when they see stars, they start to speculate if are, are all of these stars eternal? Were they there before everything was created, or they were creations? So were they, if they are eternal, then are they the abodes of the gods, or are they gods themselves? Right? So there are a lot of questions, right, by the philosophers, because they do not have that scientific knowledge. So they are based more on speculations, they're based more on intuitions, and then people, their followers, started to fight among each other on whose intuitions and whose thinking is more correct. So actually, that is something that is a wasting of time. This tradition of trying to find out, or the curiosity of to find out about the universe, continues on, and in today's world, right, we come up with this the Big Bang theory. So one of the objectives of the Big Bang is to understand how the stars and galaxies came about, right? How did they start? When did they start? And so forth and so forth. And then the second part of that theory, the Big Bang theory, is to find out the origin of the subatomic particles. Because if we say that everything is made of atoms, now atoms, they are made of smaller particles, and we learn, if we all go, I think most of us went to school and we studied chemistry, we studied physics during our secondary school years, and we know that atoms are made of protons, neutrons, and electrons. So they are called the subatomic particles. So how these subatomic particles came about, right? What was their origin, right? Did they come out just three particles, or they came from one simple particles and then after that they break up to three, or are there more than three particles? So all these things play play their role in understanding how the universe came about, the Big Bang itself, right? So that's why when we go deeper into the Big Bang, we're going to go deeper also into the subatomic particle universe, right? What are the particles, so forth, and where they came about, and so forth, so forth. So the study of the Big Bang actually is the study of the very massive big thing, which is the universe itself. The biggest thing in this universe is the universe itself. So we study about the whole universe, the vastness, the hugeness of this universe, and we also study to the very, very small things in this universe, which is the subatomic particles. So it is a wide range of study from the smallest ever creations to the biggest ever creations for us in this physical universe. That is the journey that we're going to go through and embark. So we're going to start on the huge thing first before we zoom in on the small things. So we're going to start with the universe first, and then after that we zoom in on the small subatomic particles. Once we have a bigger picture, right, of how this universe works, the mechanism, right, the gears and all the things that run this universe, then we look at our sources, our Islamic sources from the Hadith and from the Quran, and we see whether there are congruence or where things where things do not match. Right, there will be later part. So let us start with the universe itself. Let's start our journey on understanding this creation of Allah subhanahu wa ta'ala, the biggest creation of Allah subhanahu wa ta'ala in this physical universe, which is the universe itself. We start from the very basic. And why is that basic? The basic is that on Earth itself, our Earth, right? This Earth is situated in what is called a solar system. Okay, there is a moon, right, orbiting around the Earth. Our Earth is the third planet from the Sun, right? The first planet is Mercury, second is Venus, third is Earth, and the fourth is Mars. So we call ourselves as the third rock, right, from the Sun, because if you look at these four planets, right, from Mercury, Venus, Earth, and Mars, they are actually solid planets. It means they have this solid, what do you call it, crust, right? Of course, underneath us, underneath all these planets are all this molten lava, right? All this liquid in liquid form. So it's not actually solid right to the core, right? So it's solid at the crust because it's cooled down to that temperature where things can solidify. But underneath each of these four planets are all this molten lava because still hot, still forming. And right to the center of all these planets are the, call it metal core, or something that is heavy. So we are the third rock from the Sun, right? But even though we are the third planet from the Sun, we are the first planet in the series of planets in the solar system that has moon. So we are the first planet that has moon, and we only have one moon. The Earth has only one moon. If you go forward from there, further from the Sun, we have Mars. Now Mars has two moons, right, orbiting around it. Venus has no moon. Mercury has no moon, right? Now we move on further to all these, the giants, the planet giants, and we call them the gaseous planets. Why gaseous planets? Because why is it huge? Because it is full of gas. So it is full of air, full of gas, right? So we have Jupiter, Saturn, Uranus, Neptune. They're actually in the middle of that this huge planet is actually a solid core, but they are surrounded by gas, thousands and thousands of kilometers, thick gas, thick atmosphere. Our atmosphere is just about 300 kilometers at most, right? After that is outer space, but Jupiter has 10,000 kilometers of gas, of atmosphere. So then after that, if something falls from the outer part of Jupiter right into the atmosphere, it can still keep on falling for hours before it hits the solid core. So all these Jupiter, Saturn, Uranus, Neptune, they are called the gaseous planet, not solid planet. And they are huge because of the gas, right? Not because of the size of the solid core itself. Now, all these four gaseous planets, they do not just have one moon or two moons, they have many moons. And people are still discovering new moons for these all four planets. For example, Jupiter, the last count, it has more than 40 moons. Imagine 40 moons. How you want to imagine that? 40 moons. We have one moon, we got headache already. We have one moon, we see Muslims fight among each other. When we will start fasting, right? Can we see the moon? Oh, I can't see the moon. Oh, you can see the moon. It's only one moon. They can't see the moon. There are no two moons on planet Earth. Even one moon, Muslims are fighting. When will it start? When will Ramadan start? Imagine you have 40 moons, there's it, headache, finish, right? Jupiter has 40 moons and still counting, more than that. Saturn around that, 40 to 50 moons. Uranus, 30s, 40s, right? And also Neptune, still discovering number of moons circling, orbiting around these four giant planets. And Saturn has this ring right around it. We call it as ring. It's actually, for us, it's rings, but actually they are all rocks, right? Big rocks, boulders, right? That actually circle around the equator of Saturn, and they were actually failed moon actually, right? Because moon came from rocks that coalesced to each other, joined to each other, and then they form moon. So but these rocks, they were so close to Saturn, right? Every time they started, this is according to mathematics, right? They call it celestial mechanics. So if they started to form together, right, because of the gravitational pull of Saturn, because it's a huge planet, the pull is so huge, so strong, it ripped that early moons apart. So there's always this what do you call it, planets and boulders, rocks around Saturn. And interestingly, some astronomers, right, they postulate, or their theory is that this ring is actually quite recent, right? There were no rings before, so it means that there were several moons originally orbiting around Saturn, but they were ripped off, right, destroyed by the gravitational pull of Saturn, so they broke into smaller pieces. And millions of years in the future, these rocks will disappear, so there'll be no more what do you call it, that ring around Saturn. There is also actually a ring, if you want to know, a ring around Jupiter, but we can't see it because some speculate that those rings came from failed moons, or moons have been destroyed by the gravitational pull of Jupiter, but it occurred so many million years ago, so much so that most of these rocks actually fell into Jupiter, and only a few rocks left. That is why we can't see the ring, right? But when they send satellites there, they could see rocks, small rocks, boulders circling around Jupiter, just like Saturn. But Saturn, they still have a lot of rocks and boulders circling around it. But millions of years in the future, most of these rocks will fall into Saturn, and the rings will start to dissipate, right? Start to disappear from observers on Earth, like they are observers on Earth. So that is the interesting thing about Saturn. Okay. So we are the third planet. We have a moon circling around Earth, and we have actually 8 planets circling around the sun. Pluto is not designated as a planetoid. It's not actually a planet, because scientists have agreed that Pluto is actually some objects from from outside the solar system, captured by by sun's gravitational pull. So therefore it became one of the members, right, that circles around the sun, but in an orbit that is elliptical, that is highly elliptical. If you want to know, that all these 8 planets, from Mercury to Uranus, they orbited, all of them orbit around the sun in almost the same plane, right? So we have Mercury, Venus, Earth, and so forth, almost the same plane. So just like one line. So they're moving around that plane. But Pluto orbit is strange, because it goes from down to up, and then goes down again to up. So it is it is different from the other 8 planets that move almost at the same plane, right? Pluto is the other way around, and that is why, right, interestingly, if you want to know, if you want to look at all these planets with your naked eye, all right, you can see it with our naked eye. Mercury, Venus, Mars, Jupiter, Saturn, we can see it with our own eye without any telescope or binoculars. Uranus, Neptune, impossible for us to see with our naked eye. But if you want to know whether that blinking light is a planet or a star, now you look at the sun itself, right? If the sun is setting, look at the sun is setting, and if the sun has set and you can see stars there, then you draw a line from the place where the sun sets, you draw a straight line up. If you see any blinking lights that is considered as stars, right, on that line that connects that sun, it means the what do you call it, the track that the sun sets, if there is any blinking light on that track, that blinking light very most probably is a planet. That's how you know that it's a planet, because it orbits on the same plane like the sun itself. So when you look there, right, if you look in morning before the sunrise, you estimate where the sun rise, right? Oh, so this is the angle where the sun rise, and you see a very bright star over there. That is called a morning star. It's not a star, that is planet Venus. But you see another bright thing outside that line here or there, that is, those are stars. Those are not planets. That's how we identify planets. So sometimes we can see 3 blinking lights or very bright stars, right, in a straight row. Those are planets. So sometimes you can see Venus, and then we can see Jupiter, and then we can see Saturn in a straight line. Sometimes all 4 planets in a straight line, right? Sometimes, right, we can see all 5 lights in a straight line. That is very amazing sight. So we have a sun setting here, right? And then we can see we draw the imaginary line from the sun going up to the sky, and you see 4 or 5 blinking lights. Those are planets. Beautiful, right? So if you see a very bright light, that is most probably Venus. If you second brightest light, that is probably Jupiter or Saturn. If you see a little bit reddish light, right, that is most probably Mars. And if you see very faint light, very near to the sun, this is sun, and you see a very faint light closer to the sun, that is Mercury. So beyond that is Venus. And if you see any planet beyond Venus, that is Mars. And if you see any blinking light above that, that is probably Jupiter or Saturn. And that's how people can recognize those planets. Now, those people in the past, they call them as the wandering stars. They do not know that those are planets, so they say they are wandering stars among the fixed stars. And the Arabs call them as Kawakib, whereas the fixed stars, the Arabs call them as An-Nujum. So in the Quran, Allah SWT employs the word Kawakib, Kawkab, and Allah SWT employs the word Nujum. So it refers to planets, the wandering ones, right? The Kawkab, or the plural form is Kawakib, and the fixed stars, we cannot change this position during lifetime of any human beings, right? But it will change positions, right, across several lifetimes. Then those are Nujum, okay? So these are the stars. So we start with a very local solar system, which is our planets circling around the sun. Now the sun is just an ordinary star, a middle-aged star, right? Yellow in color, very ordinary, laden with a lot of metals, and these all play part in there are the major factors that can or that contribute to the what do you call it, the livability of planet Earth itself. So why planet Earth has a lot of creatures on it, right? Because it's livable, right? And why is it livable? Because of our sun, right? So there are a lot of factors for that, so we're going to go into deeper into that, but we're going to discuss on these factors that cause Earth to be livable, cause Earth to be habitable when we discuss on the last chapter on the 7th Earth itself. Okay, now the distance from the sun itself, right? No, before that, look at the size. right? The smallest is of course Mercury. We can discount Pluto. Why is this straight line? I don't know who wrote this, who draw this straight line. So Pluto is here, right? Pluto is very small. It's almost even smaller than our moon itself. That is why, right? Astronomers now redesignate Pluto as a non-planet. It is a planetoid. It's a small planet, right? Captured by the sun. Second, of course, the smallest planet is, of course, Mercury, closest to the sun. There's no atmosphere because it's so close to the sun, right? The sun's rays actually rip apart any gas that covered Mercury. So it is atmosphereless, something like that. Then after that, we have Mars, smaller than Earth. People are now talking going to Mars. I say good luck to you because you don't ever think that Mars is going to be like Earth. Mars is smaller than Earth, so therefore Mars has what they call it, a weaker gravitational pull. You feel lighter over there, so you don't have to slim down. Like if you weigh 100 kilogram, Mars you can just weigh about maybe 40 kilogram, something like that, 30 kilogram, right? It's light over there, so it's going to affect human body because Allah subhanahu wa ta'ala create us to suit our gravitational pull, right, on Earth itself. And Mars has very thin atmosphere, very cold during the day, very cold during the night, and the day is minus 170, minus 160 degrees Celsius. How can you survive in planet Mars? So people who thought that romantically, oh, let's leave this horrible Earth and go to a new planet and colonize new planet Mars, we terraform it and have water on it, good luck, right? You cannot do it. Even though if you can change Mars and you have oxygen on it, the oxygen is going to escape into space because gravitational pull of Mars is very small. Nothing can be like Earth. Earth is very unique, right? We cannot find any other place to live except Earth, and yet we destroy our Earth. Okay, so Earth is the second largest. So actually, it's the largest of the four rocky planets. Venus is slightly smaller. So if actually people want to move on, right? People want to find another planet to live, they might as well go to Venus because Venus has almost the same size as Earth. So gravitational pull is almost the same as Earth. But unfortunately, we cannot go to Venus because it's super hot. It's hotter than Mercury. Venus temperature, surface temperature is 400 degrees Celsius. Even tin can melt, right, in that temperature. You can't survive there. And it rains acid, concentrated sulfuric acid, raining on Venus. Finish. It's like hell, right? Venus, something like that lah. Of course, you can't compare. Hell is in the real hell, but it is really hot over there. So that's the size. Now compare our rocky planets to our gaseous giants, right? Jupiter is the biggest. It's called a field star, right? Actually, it should be a star, but it's a little bit smaller than the size to become a star. So it's not a star, but it's still shining. Yeah? It emits light. Look at Earth compared to all these gaseous planets. So Jupiter is the biggest. So because of its bigger size, right, Jupiter serves like a stabilizer for our solar system. So we have Sun, we have Jupiter, right? So they stabilize the solar system actually. Without these two stabilizers, you can have all these smaller planets. Sometimes they will wander around, right? Not stabilized at all. So these two and Allah subhanahu wa ta'ala creates to stabilize, right, the orbit of all other smaller planets, subhanallah. And there are also other functions for Jupiter, which we're going to discuss later, that somehow make Earth, right, safer. Yes, Jupiter is some sort of like a savior for Earth. We talk about it later on. Now, these are the size of the planets, and you look at all these planets compared to the Sun, right? This is Jupiter, and the Sun is like this. Where is Earth? Earth is here. Just a small dot, subhanallah. So you see the size of the Earth compared to the Sun. 1 million Earth can fit inside the Sun. 1 million Earth. We see Sun as small because we are so far from the Sun, right? The light from the Sun takes 8 minutes to travel to Earth. 8 minutes. Imagine the light takes 8 minutes to travel to us. So it means that if, let's say, Allah extinguish, right, the sun itself, there's no more light coming from the sun. We only know that the sun has been extinguished 8 minutes later. for the last light to leave the earth, to leave the sun and reach our eyes. Then after that is darkness. And if Allah subhanahu wa ta'ala starts the sun again after that, and the sun lighted up, right? We will not know until 8 minutes later when the first rays from the sun escape from the sun and reach our eyes 8 minutes later. That's how the distance from the sun to earth. But sun is huge, subhanallah. Sun really stabilize everything else, right? So we can't escape from the sun. It's some sort like a source of life for the inhabitants of the planet Earth. But Earth is small. Look at that, very, very small. And yet, this is the planet that people fought, or people still fighting, will fight over things that are insignificant when compared to the richness of Allah's creations. This universe, we don't talk about the metaphysical universe, just this universe, just this solar system. We fight over small things. It's like, two ants fighting on one speck of sugar. Just one speck of sugar, they are fighting each other and killing each other. Whereas they forget that there is a mountain of sugars in that warehouse where you can take. You're fighting just one small piece and you're killing each other. These are ants, and this like us. We fought among each other. We waged battles and wars. We stab each other's back, right? We take things that are haram just for the sake of things that are insignificant. And that is why you see the Prophet ﷺ said in a hadith, if this life, right, on this earth has any worth to Allah subhanahu wa ta'ala, even to the worth of just one side of the fly's wing, which is nothing. No, flies has two wings, right? So just one wing of it is nothing. It's significant, no value at all. So the Prophet ﷺ said, if this life has any worth as much as the worth of that one wing of a fly, Allah subhanahu wa ta'ala will not give food or drinks to anyone who disobey Allah subhanahu wa ta'ala, who don't believe in Allah subhanahu wa ta'ala. All the kuffars, all the kafiruns, Allah subhanahu wa ta'ala will not give them sustenance, no food, no water, because you disbelieve in Allah subhanahu wa ta'ala. If this earth has any worth to Allah, the worth of one pair, one wing of the fly. But you see, right, we can see all the kafiruns, all the unbelievers, they enjoy this life more than us. Right? They are richer than us. Allah subhanahu wa ta'ala does not stop them from drinking and eating to their full extent, to their heart's content. Right? So it shows that what? This earth has no value to Allah at all, zero value to Allah subhanahu wa ta'ala. And that is the reality. Because you look at this planet Earth and you look at the vastness of our solar system, without looking at the vastness of this universe, we are nothing. This earth is nothing. That is the reality. So we have to refocus our life. You have to refocus our goal, right? Our goal is not this life. It's the hereafter, where Allah subhanahu wa ta'ala promised us infinite rewards, right? Infinite pleasures. That is in Jannah. So we take whatever we want from this world. That is sufficient from us. We want to take more. Allah subhanahu wa ta'ala does not stop us. We want to be rich. It's okay. It's better for us to be rich than to be poor, right? But we should not be misled by the wealth of this world. We know that everything is going to live. What Allah subhanahu wa ta'ala gives us is for us to prepare for the life in the hereafter. So the more that Allah subhanahu wa ta'ala gives us, the higher the chances for us to prepare for our life for this hereafter. It's not for us only, is to prepare for the life in this hereafter, because this life is nothing, actually. Easier said than done, of course. So let us go back to this. This is our reality check, right, of this universe itself. Now you look at the sun. The sun is huge, right? But there are stars that are bigger, much bigger than the sun. Look at this slide. There is this star called VY Canis Majoris in the Canis constellation, the constellation of the dog, right? It's one of the major stars there. Now, this star is so huge, that if you look at this, the small part, the sun is just a speck compared to this huge star. And this sun compared to Earth, right? Earth is just a speck compared to the sun, but the sun is actually a speck compared to this star, Canis Majoris, subhanallah. So we have stars out there, they are huge. And if you want to look at Earth, you want to put Earth besides Canis Majoris, and this is just a one star out of billions and billions of stars that Allah created up there, right? Where is Earth? Insignificant. More insignificant than insignificant. That is Earth, right? Compare Sun, right, to other huge stars. We have Antares, we have Betelgeuse, we have Aldebaran, and we have Sun. Sun compared to Arcturus is already very small. Now Arcturus compared to Antares is smaller. So Sun compared to Antares is just about 1 pixel. And Jupiter is invisible at this scale. That's Jupiter. And Earth, insignificant, insignificant. Smaller than the smallest speck. That is Earth. And that's where we live in. That's where we fight against each other. That's why people take things that are haram. That's why people forget about life they have. That's where people think that they will live in this earth forever and ever. So they devote most of their time for things that are temporal, temporary only in this life. We have to refocus our vision. Okay. So these are the stars. Now, let's look at the distance from of the planets to the sun. Right. This is the sun. Now, we can measure by kilometers, but then it will quickly lose its meaning because it will be millions and millions and billions of kilometers from one planet to another, right? So you see, the astronomers, they devise another unit, right? They call it as AU. A for astronomical and U for unit. So they call it as 1 AU, 2 AU, 3 AU. Now 1 AU is the distance from Earth to the sun. We're always self-centric. We're always selfish as human beings. So much so that we call ourselves as Homo sapiens, right? The Homo family that thinks. Sapien has the ability to think. So because we praise ourselves. So everything is self-centered. So astronomers say that the distance from us to the sun, we call it as 1, right? 1 unit. So 1 astronomical unit, right? So Earth is 1 here. This is the blue one. And of course, Venus is 0. Maybe 0.8 AU. And Mercury maybe 0.3 AU, something like that. I forgot the actual distance. Earth is 1 AU. Mars is a little bit more. It's 1.5. Sorry. No, this is 1 AU. This is 2 AU. So it's about 1.5 AU. So the distance of Earth to the Sun is about 1.5 to the power of 8 kilometers, right? So you have 8 zeros after that. 15000000000. So how many? 1.5, no, 150 billion kilometers. That is our distance from the sun. 150 billion kilometers. It's a long way from the sun, right? So we have Mars here, very close. So all these 4 planets, right, they are close to each other. Then beyond Mars, we have this asteroid belt. We have all the asteroids there, and now people are looking at these asteroids and looking at the possibility to mine these asteroids, right, to take metals and precious things from asteroids. So you see, people fight over gold. People fight over all other minerals in on this planet Earth, right? Especially gold. People want gold. But do you know that there are plenty much gold out there on the asteroid belt? There are millions and millions tons of gold on the asteroid belt for you to take, if you can take it. See how rich Allah subhanahu wa ta'ala is. Just one speck there, asteroid belt. So what we have right here, people fight over just 1 gram, 10 gram of gold. That is nothing, right? Compared to the millions and millions of tons of gold that Allah reserved there in asteroid belt for those future generations who can go there and take and mine those golds or irons or other minerals. They can take it from the asteroid belt. But those asteroid belt is considered as about 2.5 AU from the sun. So it's quite far, right? So you have to travel twice, right? The distance from Earth to almost twice distance from Earth to sun to reach those asteroid belt. Now Jupiter is further away, right? It is about 1 AU, 2, 3, 4, about 5 AU away. So if it takes 8 minutes for light to reach Earth, and you multiply that by 6 because it's 1 AU, this is 2, 3, 4, 5 AU. So it will take 5 times 8, about 40 minutes, right, for the light to reach Jupiter. And if you let's say we have a satellite here, right, going to Jupiter, the communication between those controllers on Earth to that satellite on Jupiter, it will take about 1, 2, 3, 4 AUs, right? Or 4 times 8 is going to be about 40. 4 times 8 is going to be what, 32 minutes, about half an hour for them to communicate. So they send a signal for that satellite to have a course correction. Half an hour later, the signal will reach that satellite. So if they made that correction later, that satellite will usually crash. So they have to calculate, they have to take into account, right, the time lag for that light to travel, for that signal to travel, because signal light travels at speed of light, so it takes half an hour, imagine, right, for that signal to travel from Earth to Jupiter. So when we look at Jupiter, right, we're looking at things in the past. We're looking at Jupiter 30 minutes in the past. Right now, we're not sure. We have to wait 30 minutes later to know what happened to Jupiter during that time. So I always look at the past when we look up there up there in the sky. Right now, Saturn is 10 AU. Is double the distance of from Jupiter, from Sun to Jupiter. So it's 10 AU. 10 times 8 is 80 minutes. So it's 1 hour, 20 minutes for light to travel from Sun to Saturn. And minus 8 minutes, right? So it's about 1 hour, 12 minutes for any signal to travel from Earth to Saturn. And beyond that, we have Uranus, 20 AU, and Neptune, 30 AU, and Pluto, 40 AU. So 40 times 8 is about what? 4 times 8 is 32, so it's about 320 minutes. 320 minutes divided by 60, right? We have around what? Close to 6 hours, right? 5, right? 5.5 hours. Let's say 5 hours. 5 hours for light to travel from Sun to Pluto, about that from Earth to Pluto. So if you have somebody here and you're living on planet Earth and you say hello to this guy, your friend on planet Pluto, your friend here will not receive your signal until after 5 hours later. There's a lack of time for the light, for the signal to travel all the way to Pluto. And then he will hear you say hello, and then he say hello back, hello, and then his hello will need 5 hours to travel back to Earth. So altogether, you will see his answer after 10 hours. Imagine talking to this person for 10 hours. How are you? Wait for 10 hours. You sleep, you wake up, you eat, you drink, whatever. Then you can hear his answer. I'm fine. How are you? So you talk back. Oh, I'm fine. So are you okay? And then go forth and forth, get back and forth. 10 hours of back and forth communication. That's how vast just the solar system itself. Yeah, we are talking just about solar system. We're not moving to beyond solar system. Once we move on to beyond, the solar system is going to get incredible, the vastness of this universe. Okay, so just one last slide before we end our session tonight, right? Just look at this slide, right? We have the Earth, here we have the Sun, and then we have the asteroid belt, right? And Mars is something beyond the asteroid belt. And then we have Jupiter, Saturn, Neptune, Uranus. Where's Uranus? Here. And Pluto, because the orbit of Pluto is elliptical, very highly elliptical, something like that. Any other, all the other 8 planets, they are almost circular in motion around the sun, but Pluto is somewhat like a flattened orbit and slanted that way. So it's a very strange orbit, but now we know why, because Pluto is not from the solar system itself. It came from outside the solar system. So that is why its movement is something like that. So it was captured by the sun's gravitational pull. So beyond that, we have this Kuiper belt, and scattered disk. We're going to talk about this later on in the next session. So inshallah, we'll continue next week. Inshallah, continue our discussion and journey of this vast creation of Allah subhanahu wa ta'ala, this wonderful creation of Allah subhanahu wa ta'ala. All right, so let's see whether there is any questions or what. Okay, so we can see, this is a question, we can see both planets in front of us. There is Earth towards the sun, and also behind us, Earth away from the sun, within those blinking lights on the same string. How does that happen? Because Earth is somewhere in the middle among the planets. Yes, right? Subhanallah. See, we can see planets, sun, and also us. Now, when we see the sun, right, and this, let's say this is the sun, this is the Earth, right? Sun in the middle. Let's say my face is the sun, right? My head is the sun, and then this is the planet Earth, and these are the two other planets, Venus and Mercury here. So when we look at the sun, we can see these two planets, right? But I say that we can also see Mars and Jupiter and Uranus, sorry, and Saturn, whereas all these three planets, they are beyond that, on the other side of the Earth. But we can see them on this side when these three planets orbit around and face on the other side of the sun. So before they disappear behind the sun, so if they are somewhere over there or somewhere over there, right, our angle, we can see the three stars, the three planets, but they are on the other side of the solar system, not on the same side of us. So ours is on this sector, and the three planets on the other sector. That's why we can see them, but beyond the sun. The sun has to set first, then we can see them. Because if the sun is not there, the sun is still there, we can see the sun, we can't see the stars. Sorry, we can't see the planets because the sun is very bright. Okay, so I hope you can understand my explanation. Now another one is, does the black hole exist? If yes, is it in the Milky Way? Now black hole, right, it does exist. People have observed black hole. It has been proven mathematically and has been observed, right, indirectly and also directly. But what is black hole? There is another thing lah, right? Long discussion. But the thing is that black hole sucks everything inside it. It is like a huge vacuum cleaner, a sucker of everything. Even light cannot escape from black hole. That's why it's black. It does not emit light because any light that comes out from that star, black hole is a star actually, right? It comes out from that star. It being, because of the strong gravitational pull, the light goes bend down and back towards the black hole. So no light emitted out. That's why the black hole is black. But people can see the black hole because it absorbs gas, or it attracts gas. It sucks in gas from other stars, nearby stars. So this gas circle around the black hole, tawaf around the black hole, and because they heat among each other, so they heated up, so the gas glows. So we can see like a halo around the black hole. So that shows that the black hole is there. Now, are there black holes in this Milky Way galaxy? Yes, there are plenty of black holes in this Milky Way galaxy. And there is the biggest black hole ever in this galaxy, which is at the center of our galaxy. So imagine if there is a black hole that goes inside the solar system. Just imagine, right? There's no harm of us imagining it. So if this black hole enters the solar system, it will suck in all the planets. So it starts in with Uranus, then Neptune, Neptune first, and Uranus, then Saturn, then Jupiter, everything will be sucked in. Then after that, Mars and everything, and even the sun can be sucked inside the black hole, and there goes our solar system. It's the biggest vacuum cleaner in this universe. So as it sucks in everything on its path, that black hole will get bigger and bigger, will get better and better. So it's a very bad black hole, and it will become so huge. And that is why you see the biggest black hole is in the center of our galaxy, because it sucks in most of the stars around that galaxy. Very huge. Okay, that is a black hole. Is there a specific period of time, season month, where we can see the other planets or we can observe them anytime? No, we cannot observe them anytime. We have to know their position. It doesn't depend on season, right, or month, right? It depends on their orbits. So we have to know when will all these 4 planets be on different sectors. So Mercury and Venus should be on our sector, right? And Uranus, Neptune, and Jupiter and Saturn on the other part of sector. So much so that from our observation, they are a line, they are a straight line. But actually, this is closer to us, and then that is further from us. So that can be found by looking up at astronomical softwares, right? And internet, there are a lot of resources on that. Okay, so these are just the questions. Inshallah, we continue our astronomy journey next week, inshallah. So thank you. We end our session with Tasbih Kafara and Suratul Asr. سبحانك ربك أشهد أن لا إله إلا أنت أستغفرك وأتوب إليك بسم الله الرحمن الرحيم والعصر الإنسان لفي خسر إلى الذين آمنوا وعملوا الصالحات وتواصوا بالحق وتواصوا بالصبر. Thank you. Assalamu alaikum warahmatullahi wabarakatuh.